Okay. This is going to be a flying low and fast case study about salmon fishing off the Oregon coast. We're going to get much more specific, actually, than most of the talks you've heard before. But we have encountered most of the issues that have been talked about, including the one that Hal brought up about trust and let's see, data sharing and visualization. I'll talk about all those things. And we're Project Cruise, which is not an ocean observing system. It's the Oregon Ocean Salmon Collaborative Research. So it's a very collaborative project that includes many agencies, many individuals, and also includes the West Coast from California to Washington, and NANOOS. We've been talking with NANOOS for several years, although we have not specifically incorporated their data into our system yet. So we're talking about commercial salmon fishing on the coast of Oregon, Washington, and California, specifically here, Oregon. The way this project that I'm talking about works is a fisherman catches a fish. He takes a sample from that fish, a fin clip and a scale. He puts a barcode tag on the fish, and then he enters the data from that fish electronically, and the electronic device will also capture other information, including latitude, longitude, time, depth of catch, length of the fish, things like that. So we're working on developing this system to integrate data collection at sea basically in real time, and then hopefully eventually communicate it to shore, either satellite or cell network. So what we end up with is a bunch of tracks of the effort. We know where the boat's been fishing, we know where the fish have been caught, we know at what depth they've been caught, we know what species. We're working with Chinook salmon right now. We could work with albacore, halibut, sablefish. So we really want to generalize this. Wrong way. We needed a system to deal with a lot of data. So it's based on a website, web portals. Everybody's got web portals, and linked to a database. Then we have a set of data inputs, which include the inputs from the fishermen, not only catch data, but also oceanographic measurements made by the fishermen, linked to other databases, including NANOOS and the Pacific States, here's the analysis section here. And then bring it through to the output. And the output can be many different groups can use the same data and the same collection of data. So project managers, scientists, fishery managers. And here you have the fishermen talking directly to the fishery managers and building trust. So fishermen, marketing, we can make commodity markets here, and the general public. So education. We have developed much of this system, and of course it's not something you do overnight or even in 5 or 10 years, but it's operational. In addition, we have succeeded in sampling on the entire coast of Oregon and California. This is from 2010. The shading indicates where samples were collected over the season. And this matrix of charts here indicates that we have stock compositions and catch rates from May through September for the whole coast. And each fish, we know where it was caught within probably 100 meters. So this is an unprecedented data set. How do we visualize it? Well, we've been working on that. How do we... this is a pretty basic scientific style visualization where you have sea surface temperature and catch mapped, and you can see when upwelling collapses, the sea gets warmer, and the fish tend to be caught more inshore. we've worked on some 3D visualizations. Since we have depth of catch, we can map a cloud of fish. This is from CMOP current models, so integrating different models. We've developed a dynamic fisherman's portal, and in this case, it includes a database search section and a display. So this is kind of our version of the NANOOS visualization software. So here's a cloud of catch per square nautical mile off part of the Oregon coast. The darker the green, the higher the catch. A fisherman himself can see his own personal catch and the tracks where he fished and caught fish, where he fished and didn't catch fish. So this is a tool for the fisherman to use. We can add sea surface temperature and other environmental data. Now, one thing, that's a static picture. We'd like to get a dynamic picture, so I've tried doing movies. And here you can see locations where the catch is stepping through the year, how it changes over time. And some time periods you have less fishing, other time periods you have more. There's a pretty stable spot here. And you can then overlay the sea surface temperature on top of it and view your catch in relation to sea surface temperature or what other environmental variables we think may be significant. And with Rob's help, we've taken this same database and put it into the Worldwide Telescope, and we'll be looking at that tomorrow at the workshops. So I wanted to take, if I have 15 seconds left, to talk about where this, just take the chance to think of where we might be 15 years from now. And you can imagine some technology improvements that we're going to come up with, maybe some holographic 3D displays like they have in Avatar. One thing that we need is this is a two-way between the fishermen and the database, and, and the scientists and the managers and back. So we need better internet at sea, and maybe in 15 years we'll have that. So definitely we hope that the marine observing system is developed out by then so that we can have a more comprehensive picture of what's going on there. Also, the fishermen are collecting oceanographic data, and we hope to be able to feed that into the marine observing system. There's a data quality issue there, but once again, it makes it real time, the difference between real-time data and the old stuff. So, and then the need for predictive models and visualizations. Now, this is kind of the Buck Rogers stuff, but I think there's a social aspect to this too. And what I would like to see is I would like to see fishermen being able to make their local decisions of how to fish, what to catch, when not to fish, where to go, based on the global information that can be provided by this system that we're developing out right now. I mean, today, fisheries management is basically top-down, based on data that's last year's or last decade's, and the managers have this broad view so they can tell Father knows best to the fishermen. Well, if we can transition to real-time management and build the manager's Father knows best perspective into our models and visualizations, we can then feed that to the fishermen, give them access so that they can make their decisions in that broader context at the same time as they are using their local knowledge to feed the broader view. I think it's a really powerful place that we can get to from here. And not just fishermen and managers, but the general public, marketers, scientists to advance our knowledge, ecosystem science, and so forth. The one thing I do think in 15 years anyway, we'll still be using the same boats. So,
Great.
So thank you very much.
Thank you so much, Peter. Can you just take a seat to the side here? Thank you, Peter. You've given us some great, very interesting information. So the second member of our panel is Joe Schumacker. Joe is a fisheries research biologist with the Quinault Indian Nation who has been a longtime founding member of NANOOS. Joe, please join us.
Test. Good. You know why the Quinault Indian Nation and myself got involved with NANOOS? It's because of cool things and collaborators like the presentation we just saw from Peter right there. That was really impressive. That's just the kind of stuff that made NANOOS so attractive to us and to myself when we were first approached by Jan and others to come and get involved with this organization. The broad array of collaborators that are involved with this organization have really brought a lot of focus to bear on an area that we felt really needed some help out there on the coast of Washington, and we're finally making some headway, so we really appreciate this. Just want to give you a quick look here where we're talking about. Was there a pointer? Yeah, right there. It's one of these ways. Oh, there it is. So, yeah. So there's this big inlet in here that gets a lot of attention. And then out here, there's the ocean. I'm with the Quinault Indian Nation. This is the Quinault Reservation right here out on the coast of Washington State. This is an Olympic Coast National Marine Sanctuary map that I use freely. Thank you, guys. And this is the sanctuary boundaries you'll see right in here. The Quinault Indian Nation has a treaty right to co-manage the resources in the ocean area off the shore, as do the three tribes north of them, the Ho tribe, the Quileute tribe, and the Makah tribe. So this is a unique ocean governance area within the United States of America where tribes have rights to manage out in these ocean areas. That brings with it the added responsibilities of managing those areas. So it's a very, very large area that we manage. The Quinault Treaty Ocean area extends from down here at Westport, down in the very southern end of this picture, on up to Destruction Island up in the off the Olympic National Park, and encompasses this incredibly broad area of ocean out here. So it's a lot of ocean, over 3,000 square miles and more that we actively have to co-manage and try to get the best possible information we can from. That's it. That's where the Quinault Treaty Right exists. Hello. That's it, in that area. That treaty right doesn't exist south of there or north of there. So they have to manage this area to be sustainable for generations and generations. And when I first got to join the Governance Council with NANOOS, I was approached by Antonio Baptista. And I wish he was here today because I have to thank him. Antonio came up to me one time and he says, "Joe, you need information up there in your area." I says, "Yeah, well, let me show you something." And he showed me what they're doing with their sea glider down there. You know, Antonio, by the way, is with the Center for the Coastal Margin Observation and Prediction, CMOP. And he showed me what they're doing with their sea glider out of Astoria. And they'd gotten it up about as far as Long Beach, which is south of this picture a little bit, in southwest Washington. But they had not been able to get it up further because they didn't have any assets in place north of there, say Westport, for instance, where the Quinault fishing fleet is, that could help them to get this sea glider in place for both deployment and recovery. And working with Antonio, we've since begun a series of missions for the last 3 seasons that have worked with the, out of Westport, deployed with a Quinault fishing vessel, and back and forth through this coastal margin area, on up here north of the Quinault Canyon, then back down using their Slocum glider. We help design these missions, and then we work with them on of course, the recovery of it. So we have a great collaboration going there that came about as a part of our working with NANOOS. It wouldn't have happened otherwise, and maybe, I don't know if it would have for sure, but that's how it worked. So it's been a very good thing. We're finally starting to get some information from this sparsely monitored area. So NANOOS has a new buoy that's been in place up here off of La Push. It's fantastic. We're very happy to have that. So that's north of the area that I actively work with. We have a lot of assets south of here. Our intrepid friends at the Olympic Coast National Marine Sanctuary can get out and do some seasonal moorings off of Point Grenville and Cape Elizabeth, forgive me, and other areas out in here where we can start to get a little bit of information out there. But that's it, folks. You know, we've got these spotty bits of coverage out in this coast out there. That's about it. So it's, to me, we're getting there. We're getting some footholds in place. We're starting to get some data. We're starting to get some information that we can work with actively as fisheries managers and as habitat managers, but it's still a big black box. So we want more. So what I'm going to talk to you today about is primarily needs. That's what we do. I'm not going to bore you with this stuff. We talked about a lot of this today. What's the basic stuff that we'd like to see out here off of with our deployments that come in from that are out in either moored or mobile or even land-based. And we know that we're looking at things like public safety. We're looking at things like trying to protect us from waves, either storms or other waves. We talked about a couple of those that I don't even want to talk about because I live out there. Tsunamis, and harmful algal blooms, which is a big deal for the tribes on the west coast of Washington State out there. We have some harmful algal blooms that can shut down our shell fisheries for years at a time when they occur. But the big thing for us is, why do we need all this? Well, we've gone through a lot of that. It's knowledge is power for us. For this place-based area out there that we have on that ocean, we got to know everything we can about it. We have to know every single bit of it, that we can. We have a lot of traditional knowledge from our fishermen, from our Indian fishermen that can go out and they can tell me things that I'll just go, wow, how'd you know that? And they're amazing. And these guys have a lot of that, but we need to back it up with as much as we can so that we can maintain our ability to manage in those areas. And that, of course, gives us that ability to be adaptive in how we do it. So USAs offer information that's not been previously available, deliveries in near real time, and delivered now most recently by mobile and web apps. This is a great new addition to what we've had in the past. In the past we'd have to go searching and so forth, all over the place. Now we have things we've heard earlier today, one-stop shopping options. I've been pushing for that for I can't tell you how long. Get it all in one place. Let's go find a central location for data. Let's go get it. Something we can find and actually make use of. But what do I really want? Okay, this is what I want. I want a picket fence. I want a picket fence. I want a scattering of sensors throughout, either moored, mobile, or land-based throughout the Washington coast. I want them all the way through that poorly named California current ecosystem, whatever it is. It's up off our coast too. Anyway, we'd like to have them up through that entire area with all kinds of assets. I'd like to see full spectrum optical, full spectrum audio. I'd like to see chemical, physical, and biological sensors and any place we can have out there. Anything that will give us the information we need to know what's happening. I want to have it at 24/7, 365, real or near real-time reporting of marine conditions and activity. And then I want this, and this really gets to the heart of it, the Data Distribution and Alerts Center with sufficient and competent artificial intelligence to make decisions to alert when significant changes or out of the ordinary events occur. That comes to the data management piece of this. That's where the real key for us as managers is right now. We can go and look at websites, we can gain data to help us with things that we're doing right now, but when do we need to be on the alert for things that are happening? That's something I think is a real key, and I'd love to talk to some of our data management people that are here a little bit more about that. So I know it ain't easy, and I know that there's a lot of stuff involved with it, a lot of ifs and whens. But if we could make that work, I think that would be a real key for management decisions out on this coast out here. So that's my 5-minute thing, but let's see what else we can do for us. You can help us protect human health and safety, predict the effects of management actions on ecosystems, monitor invaluable treaty, tribal, and non-tribal resources in these areas that must be maintained, again, for generations. We can document changing conditions. We can help to augment what the Quinault people already know of the state of their ecosystem and help guide decisions to maintain those resources for generations to come. And thanks. Did I do it fast enough?
Thank you. Perfect, Joe. Great. Allan Pazar, I'd like to welcome you as the next member of our panel. Yeah. Fisheries is such a central issue, and we really wanted to get some perspectives up here. Allan Pazar is a lifelong Pacific Northwest resident, born in Washington, lives in Florence, Oregon, and has fished extensively, sits on many state and board panels, including the Oregon Dungeness Commission. So just take the stage. Welcome.
Can you hear me all right? Hello. This isn't my usual line of work, so I promise I'll be brief. I will admit I'm really overwhelmed by what I've seen here today. I've learned two things. One, I need a smartphone. And two, I didn't know a damn thing about NANOOS, and I really should. I was introduced to NANOOS several years ago at a SAFE meeting that we had in Newport. This is a group of fishermen. SAFE acronym stands for Science and Fishermen Exchange, and they're great meetings. We have a topic, we talk about it for a while, then we order some pizza and drink some pop, and we BS the master's students with their professors or the PhD candidates that have a project, and usually the discussion has nothing to do with the topic that we had, but it's sponsored by OSU and Sea Grant, and it's a wonderful program. I'd like to see more of it up and down the coast because it certainly spawns a lot of activity. Before I left here, I went down to the dock and just randomly grabbed 6 fishermen. I asked them if they knew what NANOOS was. One answer was, "Wasn't that a killer whale?" I had 4 blank stares, and one other guy said, "Yeah, I know NANOOS. I use it all the time. But tell them we need real-time current information rather than 2-day-old stuff." So I see a need for outreach and education. I talked to if there's any Oregon Sea Grant people here, and I think there are, I apologize for going under your head here, but I spoke with Katie Hildenbrand, your agent on the coast, who I work with quite closely, and I asked her if she would or could do a traveling roadshow like they did for the Marine Reserve issue. And she said, "Oh, sure, I think we have time and maybe some money left over at the end of this fiscal year to do that." And, you know, when fishermen leave the dock, albacore fishermen, they wouldn't dare leave the dock without fuel, food, water, their crew, and a current temperature chart and chlorophyll. But I was talking to Alexander, wherever you are out here, during the break, and he says the website hits drop off tremendously during the winter. The crab fleet doesn't use this. I don't think they know it exists. And I think if we're going to go to all the trouble to gather all these different data sets and put them in one place, we need to educate the users at ground zero just where it is, how to navigate it, and I think you're going to see a lot of use and a lot of hits. Those hits are going to go way up. I don't know what else I had to say here, but anyways, I'll leave this for now for the people that are a little more educated than I am here. But outreach and a roadshow for educating the users. I think that's a real component that we need to see. So, thank you.
I'm going to call up one more member, and this is a perfect follow-on. Professor Michael Kosro, who is with us from Oregon OSU, Oregon State University. I'm a Husky, sorry. Mike is not only a physical oceanographer, but he has worked with SAFE for a lot of years and has a very brief presentation to say to us about it. So, Mike, please join me on the stage. Let me launch this for you.
Great.
Thank you, Mike.
Yeah, thanks. Thanks, Jan. So I just have a little short video which I'd like to show. This is not work that I have done directly. I'm a physical oceanographer, as Jan said. I make maps of ocean currents. This is a sort of reverse outreach. This was a really nice example of NANOOS products getting out into the community. Alex Kuripov's been mentioned a couple times. He produces models of the ocean circulation and properties using NANOOS data. And he was putting the data out on the website. After one particular incident, our outreach specialist, Craig Rizian, who's been to lots of fishermen's meetings, received a complaint saying, "Hey, did you know your site was down?" And no, we didn't. That's great. I mean, that's an indication that people are starting to use this data and miss it when it's not there. This is what I'm going to show you is another indication of that. This is a video that we had nothing to do with producing. It's from a charter fishing company, and they're explaining to potential customers how they can use the NANOOS website to find where to fish for tuna.
Ahoy, welcome aboard. This is Dan, your crew on the Amigo. I'm going to go over how to use our SST chart, which stands for Sea Surface Temperatures. Here at the top of our navigation bar, you'll find a link that says SSTs here. You go ahead and click on that, and you're going to come up with the NANOOS.org assets page. And it's going to give you an overview of our west coast here. The first thing you're going to want to do is click on overlays here on the left side, and then you want to scroll down and click on water temperature and currents dash tuna. Now this chart or overlay will give you our SSTs, our sea surface temperatures. The key here indicates the temperature from 55 degrees to 63 degrees, so we can minimize that at the moment, and you can see our surface temperatures appear here. Now use this to zoom in by clicking on the plus sign. You can zoom in to get a better view of what's going on out there. Now by clicking on the screen and grabbing it, you can move it around, and as you can see here, here's our different cities and so on and so forth out here. Right here is Newport, so as you can see, probably around 50 miles you start getting into some warm water. Now although this is a good indicator of where tuna may be, it's not a 100% guarantee, but it is fairly accurate. Now you can open up your key here again by hitting the plus sign, and it'll, like I said, you can see where that warm water is, and you can even zoom in. These arrows here indicate your currents. A bigger arrow would be a stronger current, and a smaller one less. And you can see the key here indicating your knots and your current knots. Point 2 would be a small arrow, and upwards point A, and then so on and so forth. You can easily use this reference down here, 50 miles, to kind of gauge how far this water is. You can grab it, you can use that as a measuring stick. You can see there out of Newport, if you go 50 miles, you know, it's indicating that you're going to have 60-degree plus water. And you can zoom in more, and as you can also see, when you put your crosshair over sections of the ocean here, it will give you your latitude and longitude up here. So hopefully you'll find this is a useful resource, and hopefully that will also help you find some tuna. So tight lines, and hope to see you out there.
Great. Thank you, Mike.
Thanks.
Thank you so much. So you all can just stay there. I know we're taking this user case a little long, but this was a really important one for us to get some variety of perspectives here. I think we've seen some real visionary requests, some of it for technologies, some of it for needs, some of it for outreach. We've also seen some successes here. I welcome your questions right now from the audience, your perspectives, and also any comments that the panelists might want to make. But let's hear from I see a question back there, and just get those hands up high and make sure we get a microphone to you.
My question is for Mr. Schumacker. As you know, being a participant in the Federal Fishery Management Council, that our constraints, our area constraints, are largely due to lack of information about some fishery stocks, and I'll name yellow eye in there, yellow eye rockfish. Do you see any chance that the infrastructure here with NANOOS could potentially be used to lower the level of uncertainty about some of these fish stocks, perhaps using some of this infrastructure for fishery independent surveys, perhaps?
I knew you'd have a question for me, John. Thanks. Thanks. You know, for yellow eye and some of our other constraining species out there, you know, rockfish of that nature, one thing I could think of just off the top of my head would be, you know, any type of transponder type tagging that we could do on those fish potentially and track them acoustically. That might be one way, you know, and see where they're aggregating, where they're not, what the changes in populations might be over time, things of that nature. That's just one idea. For the current infrastructure that's out there right now with NANOOS, I don't really see a lot there that can help us with really trying to determine, where those species are. I think we need to expand it quite a bit to really start get the information that you're looking for.
I'd like to add on to that. The system that we're developing, I think potentially could be used if the fishers will report their catch locations, and so observe the locations of bycatch right now, and then use that information to move away from wherever the bycatch is occurring. I know they're doing this on the East Coast. I know the whiting fishery does this through Sea State. So there are various ways to do it, and I think that we would like to work with NANOOS to make that kind of service available.
I'll make one quick comment. There is an ongoing acoustic tag study in Oregon. They've moved from the beach at Cape Perpetua to the Stonewall Bank this year. It's going to be about a 22-day survey, and there has been considerable tagging done from WDF and W on the north end of the prairie just recently as well on yellow eye.
Other questions from the audience?
No fishermen out there besides John?
Les Bolton. We operate 2 tall ships on the West Coast, and boy, you hit the nail on the head. Increasing internet access, I mean, it's great that you've got an app. Once the boats are out, what good is that? Throw that thing over the side. You don't have access to the information. Being able to either expand cellular coverage farther out or figuring out a way that we can get internet access out there, I think you'd get a lot of boats reporting information. You'd be a lot more real time. And, the boats aren't running in every other day to figure out what information is new. They're out there with last week's information, and they're going to be there and until they finish their job. So I think increasing the internet access is just really important if you want to gather more information and really be timely.
Yeah, well, satellite access is available, but it's expensive and it's low bandwidth.
I'm just curious. I mean, that's an obvious problem, and I don't think NANOOS is going to have the resources to do anything about internet access. But how about something more low-tech, like having someone at home who looks at the information that is available and reports to the people at sea? I don't know of cases where that's done, but it seems like a solution that's available.
There are limited solutions available. Sorry. There are some limited solutions available. I mean, we can go HF. You can download weather that way. But you're talking about pretty high level, nice access stuff, and truly, we could get satellite communications. Pretty expensive, and that little troller that I saw coming in over the bar, that guy doesn't have satellite. We got a lot of boats out there that are trying to make a living or trying to do good work, and I think that they'd be willing to be part of a system where they're reporting their temperature. That doesn't take much. This is my position. Here's the temperature. Now you give me your information. I mean, I think that'd be a thing that we could somehow embrace, and not that this organization is going to do that, but I think that if everybody understands that we could be gathering more information, we could be a lot more effective if everybody said, figuring out a way to do that is important, then I think maybe it would show up before 15 years.
Agree with that.
Yes, Rob.
I'll just throw a comment into this, which is that, what I'm hearing here is kind of a combination, and I see this a lot in technology, a combination between describing what you're interested in getting, which would be, let's say, a particular high technology driven answer, but you want the answer, and then the engineering that would go into that. Well, you can do a satellite modem. It's expensive. You could do, 900 megahertz long wavelength radio, that kind of thing. So my comment is that I think that there's a lot of cases like this where what you need is sort of the unity of a voice to say this is the solution we need, and then you need to turn to a technology team. And I don't necessarily mean Microsoft. Microsoft has its things that it can do, but there's lots of other ways of taking care of that. And saying this is the thing that we need, right? Then how do we get there? And you let the technologist apply, supply that. That's a lot of what comes up in my job, is just showing people stuff that we have going, and they say, wow, I didn't know that was possible. And that can sort of drive the back and forth of the conversation. So I just wanted to put that out there as a way of saying that there is a way of approaching this lack of information problem, which is to state the information that you need and then ask for the technology solution.
Excuse me. So just along those lines, I don't think the technology is that far away. One thing that we do at PMEL, we have a number of instruments that we place onto various ships that gather data in real time as they go along. And we're actually starting to do that now. We're working with the Sustainable Fisheries organization to put some of these instruments on fishing boats. These instruments are sending their data back to us via Iridium satellite communications. There's absolutely no reason why we couldn't do a push-pull where every time we get data back from that ship, we can push out the NANOOS maps or whatever that show relevant information that basically we're willing to pay for the satellite charges for those sort of communications if they're willing to put those instruments on their boats. Just a thought.
Yeah, put it on a 45.
That's a great thought, Chris. I'm going to ask if there's one last question, otherwise I'm going to draw this panel to a close. Yes, John.
I just want to build off what Chris said and what some of the panel members said and what the fellow in the back said. I mean, there really are a lot of ships of opportunity out there to collect that information and get people involved in that exchange. And then I want to also point out that talked about tagging fish, and Jim Bolger's here from POST, Pacific Ocean Shelf Tracking, which helps to facilitate that kind of acoustic tagging. I'm sure there's partnerships that we can think, but I think you'd be outside the box and really taking opportunities of those folks that are going out to sea all the time. So.
Well, I think those are really good suggestions, and part of tomorrow is to do some follow-up work and to get some brainstorming on how we could really identify. Some of these things are going to be short-term, relatively straightforward things to do. Some of them are going to be longer-term. They're going to take some time and some careful thought. And we're thinking not only about the information, but also about the outreach. And Al, thank you so much for really keeping us in that vein as well. I think that these perspectives have been so important for us to think about going forward, and particularly with IUS, once again, I'm going to tell you, you get all the dirty laundry. A lot of people say, oh, IUS is just all the physical oceanography. It is not. Fisheries, biological systems, they're so critical here, and it witnesses the strong buy-in that we just had. So I want to thank our panel so much for contributing and for all your thoughts today. Thank you. And I'm going to ask our next panel. This is sort of like speed dating. So our next panel.
You're not going to hear a lot about NANOOS in my particular section of the talk. You're going to hear more about our new interactions with NANOOS from Andy in a minute. So I'm going to start off with an overview of the Pacific Coast Shellfish Growers Association monitoring program, which we established a couple of years ago. And then Andy will follow up with the specific examples from Willapa Bay and Benoir Works in Daybah Bay, where we have a major shellfish hatchery, and he'll continue on that. So this is our monitoring network. We have 7 sites. There's only 5 stars there, but we have 3 stations in Willapa Bay, which is a very important commercial bay. The reason we established this network was because these coastal bays where we work and depend on oyster larvae are very dynamic. So if we're looking at offshore buoys, it's very instructive to us, but it's not necessarily representative of the water at the end of our intake pipe. And those conditions are what we need to understand if we're going to try to produce larvae successfully in some pretty challenging conditions. So our industry is propped up by 3 major commercial shellfish hatcheries, 2 of which are in Day-Bob Bay, and the 3rd of which is where I work at Whiskey Creek Shellfish Hatchery in Netarts Bay, Oregon, which I just recently learned was going to wash away as our bar breaks through. So Whiskey Creek's been around for 30 years, a reliable producer of about 10 billion oyster larvae each year for growers throughout the region. But in 2007, we started having some very unprecedented production problems. There's always problems producing larvae, but these are long-term, and frankly, things haven't been the same since we started observing these trends. Our industry also relies pretty heavily on natural recruitment of Pacific oyster larvae in Willapa Bay. So we're going on our 8th consecutive year with very poor recruitment in Willapa Bay. So if you have a product that takes 2 or 3 years to get to harvest, and you have 8 years with very little natural recruitment, you got a big problem on your hands. So we're concerned about this. Trying to understand this, particularly at Whiskey Creek, we chased our usual suspects, which a few years ago, usual suspects for us were bacteria and other infections of larvae, but not necessarily the underlying oceanographic conditions that drive those problems. So I had a paper sitting around in our hatchery for about 2 years, and I finally, after chasing bacteria, picked that paper up and saw that there's upwelling of very corrosive waters on the Oregon coast each year, much more corrosive than we've been expecting for another 4 decades or so. And so we finally said, hey, maybe we should start paying attention to these things. And sure enough, I don't have enough time to go into detail on this, but sure enough, there's a strong correlation between the aragonite saturation state of waters in our bay and whether or not we can make money producing larvae. So it was a bit of a surprise to us, but it made it clear to us that we really need to focus on ocean conditions if we're going to try to stay in business. And I should point out, though, although you don't see it here, we never would have figured this out if we weren't thinking about, well, at the time I was using the NOAA Coast Watch browser, but looking at color plots of sea surface temperature and understanding the larger scale processes that were going on along our coast helped us to understand, oh, this is an upwelling event and nothing will live in our hatchery. So we also learned more about local effects in our bay because we have real-time data from the end of our intake pipe. This is a fairly mild swing in pH during the summer months in Netarts Bay of a point. We can do better than that sometimes. So there's a huge photosynthesis and respiration signal overlaid on that. And this is a case where real-time data may help us to stay in business. We look at the data, oh, there's a lot of photosynthesis in the afternoon. Now we understand carbonate chemistry is important. Let's fill the tank here. Okay, not here, which is what we were doing for years. So now we had some data. It wasn't necessarily great data at that period of time, so we decided to get better. So now our monitoring network consists of continuous PCO2 data at 3 sites, one in Willapa Bay, one at our hatchery in Whiskey Creek, and one in Day-Bob Bay. We also have continuous monitoring of the basics, pH, temperature, salinity, and dissolved oxygen. And we back all this up with weekly discrete samples. Okay, so we understand that these larvae are very sensitive to small changes in chemistry, and if we don't have this discrete sampling, we're going to get it wrong. Our sensors aren't necessarily the best. We're making them better, but these discrete samples are very important and to get very good information about what's going on in our bays, but also by raising the quality of our data, we're able to get attention from a lot more researchers than we would otherwise. And of course, the real strength of what we're doing here is we write down what happens to larvae every day from February through the end of October. So we have a huge amount of biological data that we're now able to line up against pretty good environmental data. We got really, really good data, and then we realized we probably need some better brains than what we had on hand. So we're able to initiate collaborations with a lot of researchers throughout the region. Burke Hales from Oregon State University helps us with our installed RPCO2 monitors. We're recently going all the way with that, by the way. We now have a continuous PCO2 and semi-continuous TCO2 monitor at Whiskey Creek, which is going to ultimately allow us to calculate saturation state in real time. But the point is, because we focused on good quality data, we're able to get these guys involved. We're also now working closely with George Walbusser and trying to really understand what the mechanisms behind what's happening on our coast. Just to finish up, we have a pretty good model so far. We're trying to extend this model to other areas of the country. So I've participated with a Sustainable Fisheries Partnership in workshops in Maine and in Virginia, in Chesapeake Bay. Those guys are starting very similar hatchery-based monitoring programs. And of course, we try to participate in the CCAN network, although we're not quite up to speed with those guys quite yet. And of course, now we're starting to collaborate with NANOOS, as Andy's going to talk about. And the next steps for us are to do better, get better instrumentation, hopefully get some more sites, and as I said, ultimately get saturation state in real time and put it in front of the eyes of the people who need that to stay in business. So that's all I got, and I'll hand it over to Andy. So.
Thanks. So yeah, this is Base Center Port right here. This is where remote setting hatchery is located, and their regular hatchery is located. And they have their intake right around here, and so that's where we put our intake for our system. This is in Willapa Bay. We also have a similar system in Nakata at the Lummi hatchery. And so water is being pumped up to this manifold right here, where initially we just had a YSI 5200 with salinity, pH, temperature, DO, and ORP, but we just added Honeywell Durafet 3 sensors and a Honeywell DO sensor to compare. So the data from the probes are going into the 5200 unit here, which goes with then the data goes into the computer here, the old desktop, and then that desktop houses the data and sends it to NANOOS, where they can show it on the website. And we also have, like I said, we can compare the data between the two different units, the oxygen units and the pH units. As far as usable data for the industry, as Allan just described, there's a heavy riverine influence outside of Bay Center, the Palix River. So that will influence the pH, salinity, and the DO and temperature. So we have pH over here. As you can see, pH is greatly higher during times of increasing tide. This is the tide down here. Increasing tide and during the high tide periods. And this goes on throughout the year. Same thing goes with salinity, increasing salinity with incoming water from the ocean. Same for August. And very similar to with DO, but you have a daily fluctuation. You get increases in DO due to photosynthesis out in the bay with macroalgae, phytoplankton. And same thing in August as well. And like I said, we had the Honeywell YSI comparison. This is the pH right here. This just started about a month ago. They're tracking fairly well together. Still have to do analysis on that. But the great thing about it is I can check this whenever I want through the NANOOS system. This is the DO reading right here. Used to track well, but I think there's something going on as far as the sensors. I think they're getting dirty. It's been about a month. So I'll be out there next week checking on the condition on those sensors. And another thing about the NANOOS system, which kind of drives me nuts, sometimes I don't want to look at it because it means things are bad. This is the salinity here. As you can see, it's consistent, but that's not good. That means it's not, the pump is not working. So I have to go out there or call them to make sure the pump is back on and back to normal. That will, and that can affect, of course, DO, pH, whatever, because there's no water there. The Nakata site, another beautiful place. This is closer to the coast. We have a 5200 unit and a computer in the shack here. Water's pumped up from this by these boats, and there's also a hatchery and about a half a dozen remote setting facilities around this port. This is another view. We're right behind the standing can. It's very nice. This is the field laptop for Nakata. I just had to refurbish it. I also call it the field crap top because you don't want to have a laptop out there that people want to steal. You just want to have something that works just barely.
Same type of results here, very similar to Bay Center, except you don't have that riverine influence as heavy. You have more of a daylight cycle. You have increases of pH due to the incoming water and due to the daylight throughout the year. Same thing with DO and throughout the year there. And how much time do I have? 2 minutes. I'll talk about the Lummi hatchery quickly. This is our other site on the Lummi Reservation. A very cool site. This is a sea pond that they constructed, I think in the 70s. And the hatcheries are over there, as you can see. And that the lower tide gate right here, that's where they pump their water. And the tide gates are functioning as well as they used to. So you get this great fluctuation of pH, salinity, and temperature data. With these drops here, this is when the water is going over the tide gate. This is the high tide periods. And when early in the year, we saw better water inside the lagoon, but later in the year, we saw better water coming in from outside the lagoon. So it's pretty much the inverse relationship there. Same thing that goes with DO, better water inside earlier on, better water outside later on. And this is the summary of what I told the growers, suggested to the growers later last year about when to pump water. Bay Center, best water in incoming tide, high tide events. Nakata, best water in incoming tide, high tide afternoons. And Lummi, best water was during the afternoons because they also had the macroalgae effect at that site as well. So that's all I got.
Okay, so my name is Benoir Eudeline, and I'm the research and production manager for the Taylor shellfish at the Quercene hatchery. And so, well, we are located in North Hood Canal in Deva Bay, and what's quite characteristic about this bay is that it's pretty deep. It goes down to 600 feet, and it has a pretty strong implication for us because, especially in the last few years, it looks like the deep water is coming up to the surface more often. Oops. And it seems to be linked when we have upwelling. Basically, it seems to be linked with poor larvae performance. This being said, we are still in the process of trying to understand why our larvae are dying. But like Allan said, we have seen at times up to 60% reduction in larvae survival or yearly production, and we are trying to figure why. So we have two intake, and historically we used to use the deep intake as our main water supply for larvae because it was below the blooms, much more steady water quality, and it was great water. Now, for the last few years, we are not using this at all for oyster production because they die in it. So we use the shallow intake, and at time, we try to raise this intake as close to the surface as we want. Our ultimate goal is to be able to correlate larvae growth with water quality. And so to try to achieve this goal, we are doing quite a lot of monitoring in our hatchery, from water quality, both continuous and discrete sample weekly for nutrients and DIC. We are also analyzing daily larvae performance for each group in the hatchery, bacteriology and weather to monitor upwelling, basically, the wind direction. Allan already said, we had 2 probes out in the bay, 6600 monitoring both the deep and the shallow water. We have 4 units inside the hatchery, which are also monitoring intakes and different processes in the hatchery. We also have a continuous PCO2 monitor. And recently installed Durafed pH sensors and Honeywell sensors. So all of this gives us a pretty good understanding much better understanding of what's going on in the hatchery than we used to. This is what we get, though, lots of this. And that's kind of where we stand. The problem is that we want this live data, and we almost want to do like hourly decision or at least daily decision about raising the intake or, what do we do about the water quality. So we have, like I said, we have two types of data measuring more or less the same water source. So why do we do this? Well, because at times, like Andy said, sometimes this tends to differ. Sometimes they are right on, sometimes they differ. And that's generally a sensor going out or something being dirty. So we tend to combine these two and create what we call a patchwork data file. And then out of this, we start calculating, high, low, average. Because the idea, what we're trying to see, if almost in a live manner, is if we're entering some kind of weird pattern, basically. And again, this is kind of a loaded question because we're not too sure what this weird pattern is. But so, after we calculate things, well, this obviously is not real time. This is a yearly, let's say, average temperature with your high and low. But at least we can compare this year compared to last year, see how different it was. That sounds trivial, but we didn't have this before, so that's a great thing. One thing we just started doing, and I don't know how relevant it is, but we started doing it, is correlating variables. So, some of them might make no sense at all, but what we are trying to look at is how this variable, I'm trying to look at it not just, because I see a lot of these graphs, like I'm graphed out kind of, and I'm trying to see what else can we do to see the data in a different way. And so this kind of came to mind, and again, I don't know where it will end up, but we do this, so, there is lots of them, as you can see, and let's see. Yeah, we end up with correlation values, obviously, and the idea is, let's see if something pops up either from 1 month to the other or 1 year to the other. So let's see, this is oxygen and pH correlation. What's interesting here, it's explainable, but it's highly correlated in the winter months, and well, in the springs and summer, it's not so much. Obviously, there is lots of productivity in the base, so that's why. But, again, it's kind of what we do. And so this was January last year, for example, the correlation between pH and oxygen, and kind of how it evolves as the months go. And again, all this makes sense, not correlated anymore, and then it gets back to somewhat correlated again. So that's just a different way, and I don't know where we end up with this. Maybe, the NANOOS, I don't know if it will be part of a product, or, I'm still kind of trying to figure out how to deal with this data. I think I have another one here, salinity and temperature. Deba Bay is normally becomes highly stratified in summer or in spring, but more in summer. So you have really two bodies of water, shallow water and the thermocline or halocline, and what happens in October, it gets mixed, basically. And so this, that's what this shows. It's highly correlated at the beginning of the year, and then it gets mixed and it gets inverted, so the correlation change. So again, this is kind of salinity and temperature. We have kind of two bodies of water anyway. This is shallow water, but there's kind of two groups there. And then as it goes, you can see that it kind of inverts and goes in the opposite direction, and then it goes back to a positive correlation later in the year. Again, it's just a different way of looking at the data. And I just did this last week. Because the biggest factor in our hatchery, again, is upwelling, the biggest cause of problem. So we just did this kind of graph. Don't know, again, how relevant it is, but that's what we call either a mixing or upwelling indicator. This is basically the difference between deep water and shallow water, or shallow water and deep water. In other words, if it's summer and you have two very much separated bodies of water, you will get kind of a straight lineage. And when you have upwelling, the two bodies mix, basically, and suddenly your difference goes down to zero. And so that's a different way of looking at this data, and at least for me, it's kind of more visual than looking at all these graphs one on top of each other. And I think I have the same for pH. This was February. I just did it a couple of days ago. So, and that's pretty much it.
Right. Thank you so much, Benoir. Thank you. So stay wired for sound and just take your seat over there at the date table. I have to make a disclaimer here. I do this NANOOS directing stuff, but I really am a scientist. And the data is just exciting to me, because I think what we think in terms of NANOOS and what we should be doing is figuring out how we can give data to help industry, to help decisions. But this came out in the fish, and it's come out even more. What you guys are doing are also helping us to understand the natural system, the measurements that you're taking, the patterns that you're seeing. It's an incredible feedback loop, and I think the wealth of data that you can collect on the time and space scales that you have are so important to the folks like Dick Feely, Chris Sabine, myself, and Simone Allan, and others who have been working on some of these sorts of situations in Puget Sound, a host of other people in Oregon. I'm forgetting people, Bert Hales and Chris Krems and others. But I just want to say this is such a great example of that synergy. So I'm sorry for just getting my little science geeky excitement out of the way there. And I would like to open the panel to questions from the audience and other comments. Yes, Rick.
Rick Spinner at Morgan State University. A great discussion of the value of the real-time data and the limits and the benefits. I'm curious about the prospective value of the use of the real-time data to initialize some forecasts, say for 48, 72 hours. Is there a need, is there a requirement for those kind of short-term multi-day forecasts?
Well, at our site in Netarts Bay, what we use to forecast is the wind. So if the wind blows out of the north consecutively for a couple of days, we know it's time to go on vacation. So we know upwelling event is coming. I would say on as far as forecasting upwelling, I think there's a whole lot we do not understand about the setup conditions before the upwelling season starts, because I can tell you that Bert just went out recently, at the springtime of last year, and that undersaturated water was a lot closer to the surface than he anticipated. So from a modeling perspective, I mean, if we could understand what the starting point each season, that would help us out a lot in a hatchery setting, because sometimes a lot of north wind won't produce a whole lot of upwelling in our region, and sometimes that water is just camped out right there on the edge of the continental shelf ready to come in. So maybe it'll maybe the model will inform us that we should shut down and go somewhere else, but it would be nice to know ahead of time.
I really liked seeing those graphs of the real-time data in the NANOOS interface. And my question is if you could have that on your smartphone in your hand, would you bring it with you everywhere?
It's right here. Yeah, it's on here.
Looks like he does. There's another question. Orange.
Thank you. This question's for Benoir. So I really am excited to see those graphs that you put up and the nice correlations. And just seeing those and looking at those, I was thinking, well, maybe because you had such strong correlations in the winter and fall months that some predictive modeling could be done to kind of help tease apart some of that relationship and maybe make more of a substantive claim to the associations between like the DO and the salinity, or maybe the DO and the temperature in those months where you had, a nice pattern come out. Have you given any thought to that, or what sort of capacity do you have to maybe push that a little bit further ahead?
Oh, I mean, we are definitely open to all collaboration. It's definitely well beyond my my abilities. And I think the two I showed are pretty well explained. I mean, and to be fair, I have not taken time to, Deva Bay has been the poster child, I think, for UW, studies, and so because of its kind of particularity with the seals and the whole bay turning over. So I think most of these are pretty well understood. I'm kind of looking for things which might not be at time. And yeah, I mean, we are definitely open with to collaboration. And one thing I forgot to mention too, so we started working with Emilio on putting all this data online, so it's going to be probably soon. And I forgot what I wanted to say now. Oh yeah, one big thing we did this winter too is quite extensive multivariate analysis and principal component analysis with all these different parameters and larvae performance. And to be fair, the last 2 years we had very, very good success with larvae production. But I think it's highly related to the fact that we had highly unusual lack lack of upwelling. The last 2 years, we had no upwelling in Deba Bay, so the shallow water stayed where it was, and sometimes we had only about 10 feet of shallow water, and the rest was, we are talking, 10 feet of water at pH 8.12 and maybe 400 or 500 ppm of CO2, and 10 feet below this, it's pH 7.5 and 1400 ppm of CO2. So it's kind of like, that's why these instruments are so important to us, because we are raising the intake as high as we can, and kind of, there's a limit to what we can do, but anyway.
Yeah, I would agree with you, Benoit. I think that the correlations that you saw make a lot of sense from what we know, but yes. I think that it goes so much beyond, because what you're seeing there, you alluded to, it's the interannual variability.
Yes.
And we also know that we're not in a static climate scenario. And some of the things, like as Rick mentioned, with wind patterns, as those starts to shift.
Yes. We are definitely, as a matter of fact, that's one of the main reasons why I wanted to talk today, is to open this data to, either the way we process them or the way, again, we do this correlation or whatever, help modelizing what's going on. And yeah, we think the deep water is definitely one of the main problems, but I'm not quite sure that it's the only one. So how do all these patterns change year after year, and what triggers it would be very interesting to know, yes.
And I think that one thing that maybe not everyone knows is the substantial economy, not just in the Pacific Northwest, but in the United States and globally, from the aquaculture from the Pacific Northwest. Could one of you comment on that?
Well, we sell about $110 million a year of product in the Pacific Northwest, and that's supposedly responsible for about $280 million in economic activity for rural communities. So I recently did a workshop in D.C., kind of learning how that works there. We titled the session, the briefing for Congress, Preserving Jobs in Rural Coastal Communities. And so we got a really wide audience coming in the room, and right as they walk into the room, the title slide is, ocean acidification impacts. So we got a lot of people in the room that we didn't necessarily want to be in the room, but I think that's kind of what we bring to the table. And just as a comment, I hear about in the year 2050 we're going to have a lot of problems with ocean acidification, and we routinely, larvae exist for 3 months in the summertime, at least Pacific oyster larvae or a lot of other larvae in the natural environment, and they don't exist on a global average CO2 condition. They exist in very localized regions that have a lot of local impacts on PCO2. So we routinely see PCO2 values in excess of 1,000 microatmospheres in our bay during the summer months, routinely. 60% of the time we're above 500 parts per million in the summer months. So we're already seeing, in Netarts Bay, so we're already seeing this problem today, and we're seeing impacts on larvae. So our goal in participating in NANOOS is to get talented people to work with us, put data in front of growers, but also to try to inform people on these values that we're actually seeing today. So.
I think one thing we're seeing is that these nearshore environments are so different, obviously, than oceanic, even than coastal ocean, and even than in the middle of the bay. That's really what's coming out.
Jan?
Yes, Chris.
So first of all, I got to say that it really touches my heart to hear these guys sitting up here talking about pH and PCO2. It's fabulous, something that a few years ago I don't think ever would have happened. And I think that this is a perfect example of how industry and government and research in general can make a very nice partnership that makes a difference in all of our lives. My point is, and something that I hope to get across to this room, is that in these days of trillion-dollar deficits and tightening federal budgets, I hope you will voice your pleasure in the interactions that we've had and the usefulness that we can provide in working together to the appropriate powers that be, because you can't necessarily assume that we will be able to expand what we do or even maintain what we've done in the past, given the way budgets are going. And we're really relying on you, the people that, the industry partners that actually have a voice in back east to help support us in those efforts.
Our industry is getting on the airplane Saturday to go to D.C. for our annual trip, so it will be brought up, I think. So.
And that's one reason I wanted to ask you to touch on the money, and also your point about rural communities. We don't want everybody living in a city, you know? The vitality of our country is distributed, and so thank you.
And again, I mean, like a company like, for example, Taylor Shellfish in Mason County, I think it's either it's one of the first 2 employers in the county, and probably the biggest shellfish producer in the nation. So I mean, it has a lot of ramification with local communities and promoting clean waters, which is a big important one. Hood Canal is, as you know, a big one, and so well, I work for them, so I think it's important. But
I know 5 people in Mason County, and you employ 3 of them. That was a joke, sorry. All right, given the time, thank you once again, this panel. Thank you so much. And our last speed date before the break is going to be on alternative energy. So I'm going to ask Belinda Batten and Brian Polagye to come and get wired for sound, if you would. Here is for you, and just go ahead and clip that on, and then let's turn it on right now, and then Brian.
How's that? Can people hear me?
Great. Okay, and I need to do the magic button that makes it so great. So Belinda and Brian are both directors of I've got to read it because my brain is going wacky, Northwest National Marine Renewable Energy Centers, respectively, from OSU and the University of Washington. Belinda, thank you so much for being here.
I want to thank the organizers for inviting me today. This is my first exposure to NANOOS. I'd heard the name before. I'll explain why I'd heard the name before, but it's really been a pleasure to be here with all of you today. So I'm a professor at Oregon State, and I'm the director, as Jan said, of NEMRIC. We'll use that acronym. It's far easier to roll off the tongue than the long word. I want to tell you a little bit about NEMRIC because I don't assume that you all have heard about us. In 2008, Department of Energy put out a funding opportunity announcement to create up to 3 marine renewable energy centers in the U.S. The UK had really set the stage on both wave and tidal energy, and the U.S. decided it was time we joined the fray, that there was an opportunity here. And they set up 2 centers in 2008, the one that we're a part of, led by Oregon State, partnered with University of Washington. Oregon State focuses on wave, University of Washington focuses on tidal. And since then, we've together branched out into offshore wind and want to grow that area. And then you can see that Hawaii has a center, and Florida Atlantic has a center as well. The Department of Energy said, we want you to advance the industry. We want you to facilitate development of these devices by doing research and working with developers. We want you to help the regulatory agencies understand what's going on and develop policy decisions that make sense. An example of that would be what's now the Bureau of Ocean Energy Management. When we started, if you talked about putting something out in the ocean to get energy, they thought, oil drilling, oil platforms. And all their regulations were structured around that. And so through working with them, they come to understand that we will put energy devices in the water that are not extracting an irreplaceable asset. That's the kind of things we do. Close key gaps in understanding is just a cryptic way of saying we're doing research. And we're working with students. That's our job as universities. And so if you look around at a lot of the developers and some of the national labs who are doing work in these technology areas, you'll find students from the University of Washington and Oregon State working there. And we've got some of our partners there. There's a lot of other people that we partner with that aren't on this list, but those are a snapshot of some of them. So when we look at this problem, I'm focusing on the wave energy part now, and then my counterpart Brian will talk about tidal. The wave energy part, we have 3 legs of the stool, which we think are really important and somewhat unique. And this is a reason I think we were chosen by Department of Energy. When you poke around the country, you'll find lots of people who are doing one part of the puzzle, but not all parts of the puzzle. And while I've given aspects of this talk before, I'd never been asked to focus on the ocean observing piece. And so when Jan said, talk about how ocean observing works with sightings and operations, and I looked at these 3 circles, I thought, wow, it's sort of pervasive in this problem. When you look at the technical side of the problem, you're not going to do a good job at extracting energy from some of these devices unless you really know what the waves are doing coming in, and then you can leverage that to do an outstanding job of control and maximize the energy extraction. The ocean observing piece is key for wave forecasting. And then a lot of the things we're talking about with the environment, when you get right down to it, is observing what's happening out there. Either observing sand transport, observing the marine biology response to sand transport, looking what happens with the marine mammals. And then when you think about gathering all that information, the more information we have, the better case we can make with our public outreach. We've spent an awful lot of time talking to the public about what this industry could mean for them, and I hope we spend as much time listening to the public. One of the things we've seen in Oregon with some of the developers is sometimes they trump in like they own the place and alienate communities because they are not listening. So my ideal would be is if we had a test site with cameras all around and could show people 24/7 what's happening and whether marine mammals are interested or whether they couldn't care less, that would be an ideal to me. I realize that's totally unrealistic, but that's what I would do if I could wave my magic wand. So to give you a sense of what we're looking at in terms of technologies with wave energy, if you could think of almost anything you could think of to extract energy from the ocean, somebody's trying to do it. So here's an example of the Polamis wave energy converter. It's a sea snake. It's very long. It's built in Scotland, and it just sits on top of the ocean. These are some of the kind of devices that give people some concern about viewsheds. But they're fairly interesting. They work through this kind of motion, sitting on top of the water. Here's a dramatically different device. It's in the near shore. It's called the Oyster. And it's called the Oyster because it goes up and it goes back and forth like this. As surge goes by, the top piece will go back and forth like this, creating energy. That one is a tricky one for Oregon because it doesn't like to be covered with sand. And with all the sediment transport we have, it's much more suited to a rocky environment. This is one of the things we have a hard time with some of the developers is trying to explain that their device may not sit very well with the physical environment and you can't change the way the ocean works. But that's, again, one of our outreach issues. Here's another example that doesn't sit out in the ocean, but it sits on the shore. It's called the Limpet. It's on the island of Islay, Scotland. It's been there for about 8 years, I think. And it's called an oscillating water column. The water comes in and whooshes into the device and then spins a turbine. And then as the water goes back out, the turbine spins again as the air is sucked through. There's also a version of that can sit out in the deep water. But this one has some interesting implications for protecting a jetty, protecting erosion, that kind of thing. Here's the kind of device that everybody thinks about when we go and talk to the public. This is the device that everybody seems to think we're talking about. It's Ocean Power Technologies Power Buoy. It's the 40 kilowatt version that's been tested in Hawaii. They've got plans to put an array of 10 150 kilowatt buoys in Reedsport, Oregon, and their ultimate full-scale device is going to be about 500 kilowatts. And full scale, this device is massive, absolutely massive. You're talking 100 feet across. And so these are the things where people begin to really get anxious about what they look like, how they'll affect the environment, how it'll affect ocean uses, what's going to happen to fisheries, what's going to happen with marine mammals. So again, our mission from Department of Energy is to help test these devices and figure out what's real in these spheres and what's not an issue. The last device I'll show you is Columbia Power Technologies, Manta or C-Ray. This has been deployed in Puget Sound for the last year. And this is a device underneath the ocean. It looks like one sort of stalk, and then it's got these two floats that go up and down, gathering energy from the waves. So these last two devices are two that definitely benefit by knowing what waves are coming at them and being able to use active control to maximize the energy extraction from the waves. And the one device I haven't shown you here is the device that you can't see from the surface. And this is another thing I try to emphasize with the communities, is there are devices being developed that sit either on the bottom of the ocean or in the mid-column, and they don't have viewshed issues. Those devices, you'd want to know how to make sure that you delineate around them so that you don't have interaction with fishing boats or with trawlers or that kind of thing. But as you can see from this spectrum of devices, what we're going to see when these things get commercialized is really for the future to hold. So one of the pieces that's been done at Oregon State, this is where I heard NANOOS before. This work had been done on wave forecasting and is posted on the NANOOS website. This was done by one of our professors, Dr. Azkan Haller, in oceanography. And the wave forecasting is very important, both where you put the wave devices in terms of where the resource exists, and then doing forecasting that can help the utility companies prepare for what's coming at them. If there's a big 100-year wave coming at a device and they need to lock it down, that type of thing. So the upper picture there at the middle is I didn't bring the movie with me because I didn't want to risk it not working. I have a movie there actually of data from the National Center for Environmental Prediction. It's showing the Pacific Ocean for the most part, and when it animates, you can see the waves going from west to east, like we all know they do. And then what you have down in the left corner here is the upper quarter of the Pacific, so along the west coast of the United States. Now there is Wave Watch, as we heard about earlier today. Wave Watch from the National Weather Service has data on the Oregon coast, which you see on your right, but there's only a handful of points there, and none of them are valid on the coastal shelf, so they don't really help us very much when we're trying to get a good forecast of the waves for the purposes that I mentioned. So what Dr. Azkan Haller did is she took this basic wind data. She didn't use the wave data. She took the wind data and then developed 3 intersecting domains along the Oregon coast that are valid all the way up to the near shore. And using only the wind forecast, she's able to get data that's accurate up to 15%. And so now what she's going to do is work further with some advanced techniques, artificial neural networks, that kind of thing, to remove the errors, that remaining 15%, see what she can do with that. So this is one place where I think it's very easy for us to talk about what we're doing with the ocean observing piece and how critical it is for our mission. I want to mention just a little bit about our Newport Open Ocean Test Site. Department of Energy wanted us to open a test facility for wave energy. And so we decided that we were going to work on this. We worked with the coastal community, and we initially targeted the light blue square over there, the NEPA study area, to put the test site. And then the fishermen helped us pick the blue square where our test site will be. Devices will be able to be tested there. The site will be open year-round, and what we've got on the left-hand picture here is a little schematic of a device connected to our tri-axis wave and current buoy, and down the corner we've got what we call our Ocean Sentinel, which is going to be used to gather data about the device. So let me tell you a little bit more about that. We've got the Ocean Sentinel. Mobile Ocean Test Berth is what MOTB stands for. It's based on a 6-meter Nomad design. We're working with Axis Technologies in British Columbia to develop this. The initial average power rating of 100 kilowatt average means that we're going to be able to take devices that are rated up to that and connect them via an umbilical to our MOTB to see what's happening with this device in the water. What kind of power is it producing? What kind of peaks? What kind of average? We'll be able to provide power back to it if it needs it for active control, and then we'll have data transmission back to us through wireless telemetry. The device, we don't really want to have this connected to a device in the winter when we don't really know how these devices work yet. While we've got a lot of confidence in them in the summer, that might be a little bit more than we want to do. So we'll do device testing connected to this in the summertime, and then we can use it for environmental testing October to May and gather more information about what's going on out there. And we expect deployment to be hopefully this summer if we get all our permitting done. So at this point, I'm going to turn it over to my colleague, Brian Polagye, and he can talk about what we're doing in tidal.
Thanks, Belinda. So when David Barton asked me to, in a similar way, to talk about how tidal energy could use the information that's coming out of ocean observing systems, I thought, well, there must be a way that we can use this. And as I started thinking about this, I realized that not only were there many ways that we could use the information coming out of observing systems, but there were ways that this information was already being used, and also ways in which tidal energy and marine renewable energy development in general could actually feed back into the ocean observing community. So when I talk about tidal energy, one of the first things people often say is, what does a tidal turbine look like? What are you really talking about? And in a modern sense, when we talk about tidal energy, we're talking primarily about hydrokinetic tidal energy. That's devices that, say, superficially resemble underwater windmills and are converting the power in fast-moving tidal currents to electricity. The industry has accelerated quite rapidly over the last 5 years, in part because it can leverage so much of what's already known from wind energy. So the three devices you're seeing along the top there, one from Voith Siemens, one from Tidal Generation Limited, and one from Verdant Power, are all obviously very much derived from wind turbines. And in fact, the one in the lower left there is a marine current turbine CGen that's a 1.2 megawatt rated device that's on the scale of a commercial wind turbine. That went from 100 kilowatt scale to megawatt scale in about 5 years. So the industry is really being accelerated quite rapidly. But on the other hand, you have devices on the right there, like the Open Hydro turbine, that's a high solidity horizontal axis turbine, or Ocean Renewable Power Company's vertical axis cross-flow turbine that look very different than a conventional wind turbine. And so the message is that the technology is evolving quite rapidly, but there are many competing options. And what tidal energy looks like today is much like wind energy looked like 30 years ago. Okay, so how does this all work into ocean observing? Well, one of the first things you think about when you're working on a tidal energy project is siting. And the first thing you look for are strong currents. You're looking for locations that have 3 to 4 meter per second maximum velocity, moderate turbulence intensity, but they're often characterized by sharp spatial gradients. And so what I'm showing here is an example case for Puget Sound. The red star there is Admiralty Inlet. That's about 50 miles northwest of where we are right now. And the inset is showing the area right off of Admiralty Head where there's a proposed project to develop tidal turbines. And each box shows the estimated power output for a turbine at each location. So you can see the red circle has about 350 kilowatt power output. We go 2 kilometers to the west, that drops by about 10-20%. We go a kilometer to the east, it drops by a factor of 3. So clearly we need to understand the currents at these sites in order to understand where devices should go. We're talking about water depths of 40 to 80 meters, and generally these sites are scoured cobbles or bedrock. Now, almost every project that I've seen get underway here has made its initial siting decisions based on IOS data via the National Ocean Service. And as these projects have gone to these sites and started thinking about finer scale development, they've been generating new data and feeding that back into the process. So this is very much an iterative partnership more than simply consumption of data. Most of the reason we're undertaking pilot projects over the next couple of years is to improve information about the environmental effects of tidal energy turbines and also understand how they perform in the marine environment. And to address this, we end up using a lot of different instruments to answer high-priority technical and environmental questions. For those of you in the oceanographic community, active sonars, Doppler velocity measurements, and optical cameras are all fairly commonplace. We're using the same tools, in some cases, to address the very same questions. The challenge, of course, in this is that as you're using these tools, you have kind of a range resolution trade-off or a intensity resolution trade-off in that you can generate very high volumes of data very quickly. For example, if we're interested in fisheries issues, we could obtain very high resolution images of fish using optical camera systems and flood ourselves with data, or we could obtain many more low resolution images and maybe be able to tell something about what's going on in an area but not get down to a species level. And these challenges of high data throughputs, data management and archiving, post-processing of data, and forecasting of episodic events so you can deploy monitoring systems when they're likely to obtain the most information, all have clear parallels to ocean observing systems. And finally, there's a very strong potential here for sharing infrastructure. On the right side here, I'm showing a map of Snohomish County PUD's proposed Admiralty Inlet project. That's a project that we're quite involved with at NEMREC. Admiralty Head there again. Let's see, do I have a... Well, I guess not. There we go. The two blue triangles here are a pair of open center turbines that would be deployed off of here for a period of 3 or 4 years. These black lines are power cables going back to shore. And this is, in one sense, a pilot project to demonstrate marine energy. On the other hand, you can think about this a different way as two 400-ton foundations on the seabed with multiple channels of fiber optic communication to shore and about 2 kilowatts of power available for instrumentation, which should bear a striking resemblance to some of the nodes. And so there is a possibility here that tidal energy projects and wave energy projects could really extend the reach of observing nodes into high energy environments without a large investment. And so as an example of where this could possibly go, we're working with the Washington Department of Ecology to deploy dissolved oxygen sensors down on these foundations as a way to feed into the dissolved oxygen monitoring program. So a way that this infrastructure can be basically used by others. And obviously there's an opportunity to leverage best practices here in deployment of instrumentation, maintainability, and power and communications architecture. So in summary, it's not just a question of how tidal energy and marine energy can use information from IOS. There's also a real possibility of using these installations to benefit back to the broader community. So thank you.
Thank you so much, Brian. Okay, wonderful. So I'd like to kick off some discussion and question answers for this panel. I see a hand up there, and get those hands up so we get the mics coming to you. I think maybe there are even two over there. Here, let me give you this one.
I know. Let's try now.
Thank you. At the Oregon Hatchery Research Center, they're currently working on having salmon and steelhead gauge the effects of the magnetic signatures of various rivers at the mouths and checking on how that affects the homing of those fish. I understand that cables for transmission is very expensive, so most likely these devices, regardless of the type of device, will be located near population centers where you need to transmit the electricity, which is near most of our ports, which is near many of our salmon and steelhead bearing streams. Can you guarantee that we're not building electronic dams at the mouths of these rivers? Has there been any research as to the magnetic effect, the magnetic field that you're creating with these?
That's one of the things we'll be doing at our test center. So one of the things we've been advocating in the state of Oregon when we're talking about where to place these potential commercial arrays is that we don't know all the answers yet. And so where I see things going is that the community is very much behind having these test centers where we can put the devices in, do a variety of environmental testing. That would be one, to figure out the impact before we start locating these devices in places that would be hazardous. So before they start developing a commercial array, we'll have information about those kinds of details.
And to add on to that, it's not research that we're working on, but the national labs, including Pacific Northwest National Lab and Oak Ridge National Lab, have been doing laboratory studies of potential electromagnetic effects on different species. So it is an open question and one that needs to be resolved in order to make proper siting decisions.
Other questions? I'll take up some slack here while people think. You know, I find this discussion of alternative energy always really interesting because of the very essence of just what came out in that question. And as we think about our need for energy, you know, so we have coal, we have oil, we have, you know, and we're creating things like ocean acidification and all of these other things. We're worried about impacts on these things like tides and winds, or excuse me, and waves. And I think, you know, some of the people closely linked to the resources are saying, you know, are you sure we're not going to have impacts? And you're saying, we're going to do the tests, we're going to do as best we can. And so once again, it's that trust. Sort of like, will your test be good enough? But I think that our world really faces this as a huge issue because we don't really have good alternative sources of energy. You know, the winds kill all the bats, the solar, you know, I mean, no matter what you do, there are issues. And so I think what we really want to hear is how best to have the most information that can advise this project in the best way.
To add on to that, I think one of the interesting things about wave and tidal energy and offshore energy in general is that because the technology hasn't really achieved a real level of convergence to a single design, there's time for this environmental and social information to really influence engineering decisions and converge to devices that are not just economically beneficial, but also societally and environmentally compatible. And I think that's something that we're actually addressing head on with the development of this industry that we haven't necessarily addressed with past generation technologies.
There's been a lot of discussion in Oregon about the territorial sea plan. And one of the things that typically comes up at these meetings is oh my God, you're going to ruin the view at Cannon Bay. Well, you know, I can understand community fear because something like that would be horrible, but that's one of the real values of the discussions in the test centers is to get the input so we can say, okay, no, that makes no sense to put a device at Cannon Bay that's going to ruin the view, or let's test devices that will be submerged and what kind of environmental effects do they have, and might that make sense in an area like that where you do have a population center and a need for electricity.
So I appreciate the statements you made about the possibility of putting sensors, scientific sensors, onto these platforms, and that's a great idea. It just occurred to me, though, that another area of intersection that might be fruitful from both sides would be biofouling research. You know, I'm sure you guys are very concerned about potential biofouling issues with these sorts of devices, and it's of course something that the scientific community is always struggling with. So that might be another area of mutual benefit if we could work together on those sort of issues.
I completely agree.
A microphone for Rick, please.
Most of the discussion has been about scaling up, and if you'll bear with me for a minute, 35 years ago I was involved in a program called the High Energy Benthic Boundary Layer Experiment, where we were trying to figure out how to power up transmissometers at 4,000 meters depth for periods of 6 months at a time. We didn't have the technology to scale down, if you will, especially on the tidal side, to provide the kind of power that might be needed in highly active benthic, deep benthic environments. Is there any thought to the translation of the research you're doing to providing small-scale power supplies to remote regions in the ocean where there might be particularly dynamic currents?
I can show you a picture of a prototype micropower system to address exactly that question. We are thinking about both the utility scale and also scaling down to that micropower scale. So yeah, very active area of interest.
What kind of powers are you looking at?
10 to 20 watts continuous.
Other questions? Are you getting the kind of data support that you need? I mean, the obvious answer is no, right? But if you but from your perspective, what is going to be maybe the thing that's going to be the hardest for you to maybe have measurements on time and spatial resolutions that could have unanticipated consequences.
I'm probably biased because I'm a controls engineer, but it would be that wave data that you can use to really leverage. And one of the things we're talking about is if you have an array of buoys, actually using the external part of the array to feed data back of what the waves look like. And then, of course, you're not going to operate the furthermost line in the array optimally, but it would help with the others. But that's one of the ones that, from particularly the time resolution, is one of the most critical and potentially difficult to get.
Mm-hmm. I guess from my standpoint, it would be studying some of the fisheries and marine mammal interactions with active sonar. There's been a number of examples of tidal energy pilot projects that have gone online and tried to use active sonars to address these questions and have actually been overwhelmed by the amount of data they've generated to the point that they aren't able to analyze it and actually answer the questions they set out to in the first place. So collection of the data is in some cases less challenging than managing and interpreting the data.
And imagine that. Biological systems are awfully patchy, aren't they? And that's really what we face. And I do research with students, and we're trying to look at patterns of fish, in San Juan Channel in fall, and it just on that small scale, just the variation. So that I think both of those suggestions are potentially something that as we think about how ocean observing systems go forward, those are things that contributions could be made, particularly if we develop some of the wide-ranging technological advances we're discussing here.
One of the things I didn't mention, but I'd had it on my notes, and that was I think there's a lot of possibilities for using AUVs that we haven't made use of yet, but once we have these devices deployed, I think we'll be using those more to go and look and see what's the condition of our mooring system, for example. Mm-hmm. And so one of the things we've got that's been useful is the OOI project at Newport, and being able to leverage that connection. It's been a real asset for us with this new test facility going in.
That's really true, and I know that on both of your institutions, the strong inclusion of students, student research, graduate students, for the fundamental work is really a landmark of your work, and I think something that is so fruitful for us going forward, because students have new ideas that dinosaurs like us don't always think of. I meant that me, not you. Yes, another question.
I was just wondering if you've been factoring in some climate modeling in relation to sighting, since we heard earlier in the presentation the potential impacts of climate on shifting of waves and currents.
I don't believe any of the researchers at OSU have been doing that.
Neither at UW, though part of that, if we think about kind of tidal current dynamics, the effects of climate change on tidal currents I'd expect to be relatively minor, since it's a gravitational rather than atmospheric forcing. That being said, we did at one point think about looking at marine renewable energy and the potential environmental impacts of that as a counterbalance to rising sea levels in a way to kind of use one as an engineering solution to the other. But that's more, I'd say, high concept than really any chance of near-term application.
All right. Well, I want to bring this to a closure and thank you guys both for this wonderful panel. We, first of all, let's applaud. Thank you so much.
Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.